Yeah.
Brilliant. Namaste and welcome everyone to the Transitional Artificial Intelligence Research Group workshop series. Today we have Dr. John Hawkins from Playground XYZ. He's a chief scientist at Playground XYZ, which is an edtech company. And Dr. Hawkins is an Australian data scientist, and he has written a book, Getting Data Science Done. And he holds a PhD in computer science and has more than 20 years of industry experience. And Dr. Hawkins is also a co-member of our research group, and we are thankful that he has agreed to give this seminar. Thank you, John.
Thank you, Rohit. Awesome. So everyone can hear me fine, I hope. Yep, smiles and nods, excellent. So the idea is to take you through a basic understanding of how you use GitHub for doing data science work. And there's a couple of motivations behind this. One of the core one being is that there's a culture that's emerged around Git, which was it's turned out to be the most successful of what we call source control systems, which basically means a way of pushing source code somewhere so that many people can work on it simultaneously. There used to be others before Git. Git's come out to be the dominant way people do it now, but it's more than that now. There's actually a whole culture and a way of working that's emerged around it. GitHub is a private company that runs one of the most popular source servers for Git, and has a lot of additional tools that has influenced the way people use Git. So one of the many things you can do, apart from managing your source control, it's a way of managing communication and documentation around your project and sharing that communication and documentation. It's a way of actually processing workflow management, meaning who's doing what, how tasks are done, how things like code reviews get done, etc. And then it's also part of the culture is the way you break up work and complete it in a way that encourages a kind of flexibility. And is that just the chat, is it? Okay, cool. The way you break up your work and to encourage sort of a more active, ambitious development process. So the core idea here is, as well as being a useful way of sharing projects in research, in academia and data science work, if you choose to go into industry and you have to work with people in industry and you interface with engineering teams, they will expect you to do certain things with Git and how you work with them. So these are good fundamentals to know. And I've found that adopting these ideas can make me more effective. So I'm going to go through sort of 4 principles in this talk. Initially, just some basics, sort of really simple Git commands for those who are still fairly new to it. I'll talk a bit about the importance of using Markdown, which is a very simple templating language for documenting things, and how you can use that as the kind of the core entry point for people to move through your project. I'll talk about the use of branches, which are a critical way that you sort of break up and work on individual tasks. The philosophy of pushing your code regularly, and then finally merging using pull requests, okay? So basic Git commands, you can clone a repo, which means you get a link to a repository with the git clone command, like that up there. So if you can do this with public repositories or your own. You then, these are the kind of the 4 fundamentals you'll do all the time. You then add a file to the repository. Once you've added multiple files, you can commit them, adding a message describing what you've done in that commit, and then you push the commit to push it to the repo. So let me jump. I've got a sort of a simple code base here, a simple empty repo here that I'm just going to copy the HTTPS link to that and come across to my terminal. Am I there? Yep. So clone, and that's going to clone that repository onto my local machine, and I can change into that. So I'm using, this is a Unix style command line shell. For those of you not familiar with it, there's similar things you can do on a Windows machine. So demo repo, if I ls -la, which just means list the repository, basically that .git folder gets created by Git, which is where it stores all its configuration. And then the README file is something that I created. So this is really standard Git to have a readme.md. MD stands for Markdown. Now, one of the first things is I think this is what's one of the ways that a kind of a standard practice that's probably not documented anywhere is that because the README is the central part of your project, it's good to maintain any changes you make, keep a kind of a high level summary of what's going on there, and then use headers to sort of break that up. So one thing I might do, a common thing you do is at the top of the README, just have a simple description. This is a demo repo, nothing particularly remarkable there. And then use the hash symbol here is symbolized as headers. A double hash is a subheading. So I might say data here. It's the first thing people often want to know when they come to a research project is where does the data come from? So I can say data for this project sourced from, and then the next thing I'm going to use is a markdown link. So the syntax for markdown links is square brackets for the link text, round brackets for where you want to go to. So wherever my data repository is, I'm just going to, I'll just put a link to my website for the sake of showing you that it actually works. Snowzone.com. Cool. And then so data is a critical thing. The next thing you might want to do is have execution or running experiments, something like that about how someone can reproduce your work. So here it could be some documents like run this, then run this, then run that, like describing all the steps that need to happen. I think a decent practice is actually to have something like a master run script. So you can say something like execute all experiments with run.shell script. And you can also, as well, make that into a link. So up here, the link I had here was to a web resource anywhere on the internet, but the links are also local. So if it's just something that GitHub is not going to recognize as a URL, it will consider that to be a local file. So I might and it will also recognize directories as well too. So I'll give an example of that. You might say, what the heck, what's going on? Sorry, someone wants to get in. Do I have to say admit? Cool. Excellent. That's what I'm in charge. So back to my repo. So I might say something like, I could also say process data. Another link here. And oh, they've muted themselves. Cool. So here you can see that I'm just saying the name of the file here in the square brackets, but I'm actually putting the full path in the repo scripts/process.py there.
Probably you can also put a hyperlink.
Yeah, so actually I'll do that up here. I'll make this one a hyperlink explicitly. So this here, the link I put here at the top, if, for example, you might be linking to MCI machine learning repository, this could be a link in Google Drive. It could be, many different places. A common thing you could do. So what I was going to talk about is you can store some data in GitHub. But generally it'll balk at files once they get over, I think 50 megabytes is about the limit approximately. Yeah, 50 megs where it starts to balk, and then it tries to get you to use their large file storage. So a good practice is to maybe create a data directory, put a script in there that just tells people how to get the data, like a wget or some kind of script that will copy all the data resources your project needs. So that way, someone who wants to replicate your work clones the repository, goes to the data directory, sees a script that tells them how to copy all the right resources, and then they have all the data they need. Yeah. So if it's small files in the repo, large files, links to external repositories is kind of a good practice. Excellent. And then finally, this is all kind of focusing on the README at this point, but then another good practice is maybe something like results. So high-level summary of what the results of your project are. There's a whole syntax for writing tables directly into README files. So quite often I have a separate markdown file that just has a summary of results with tables so people can see it. But you might also have links. If you've got an overleaf version of your LaTeX document, or once the publication's published, you can include that. You can actually include BibTeX format for the citation for your paper as well, directly into the README, which is a common thing you see a lot of researchers do. So there's good ways to encourage people to cite your work once they've sort of seen how the experiments were conducted. Does that make sense? Yeah.
Point where you said us feeding in the data.
Yeah.
Like, I'm a bit confused as to regards to say data for this project sourced from data.
Yeah.
So in the execution,
Yeah.
the data
Sorry.
of the process.py, is it equivalent to where the data is?
Yeah. So let me say, all I'm saying is this website, this is just a link to a website where the data came from.
Okay.
And then what? So in that instance, say it's the UCI machine learning repository, you put a link directly to the place where they can go and directly download that data set. If it's more complicated, if you've got data from multiple places, you might want to write here instead. It might be something more like data for this project came from multiple sources. You can put a list, maybe. Yeah. Yeah, and then something like see the script, whatever this is, it might be sort of like data fetch underscore data dot py or shell or whatever it is that replicates the process of copying all the necessary data. Does that make sense?
What if the data is like in your desktop?
Yeah.
It doesn't have a site.
Yep. So there's a couple of options you've got there. If it's small, you can put it into the repo directly. You can link to it. If it's large, you could use Google Drive allows you to make data sets publicly available. Yeah. So plenty of researchers. I've contacted researchers and they said, yeah, I'm asking if I have their data. They've just given me a link to a Google Drive account where they had their data. But it can be anything, any file storage on the internet that you can put things onto. You can usually also get a URL for that so other people can make a copy of it. Yeah. Please come in French to ask questions, then it will be recorded in the Okay, cool.
I just added some additional resources into the chat that relate to what you're doing that I've found useful. So people may want to look at those as well.
Well, can anyone read? Can you read those? I'm going to go over here to read them. That's fine. I mean, you can go it. Oh, yeah, I think that's like a tables generated for Markdown. Yeah.
Yeah, that's right. I've found that useful when producing Markdown documents. And the first one's a self-paced tutorial. It'll help them do some of this.
Awesome. So, and then where were we? Back here, some kind of high-level summary. Oops. High-level summary or more, or links to documents, etc. Yeah. So I've just updated that README file. I simply run a git add on that README doc. I can now git commit it with the -m stands for message. README update, and then git push. I think it's going to, yeah, this works. So now if I come back to my repository now, my demo repository, and refresh it, you'll see everything I put into that README is now in there, and you'll see the links are active. So, you know, so this one, the URL one will link to my website. Oh, can't seem to access it for some reason. But there'll be, and these ones won't work on GitHub because I haven't actually created those files yet. You'll get a 404. So I started the README saying, here are the scripts I intend to create, but none of them actually exist. And so it's now up to me to sort of fill them in. But now you get a sense of that high-level view. Anyone coming to my project can see immediately data, how to replicate results, and maybe links to documents, etc. So that's kind of the first part of that. Back to the slideshow. Cool. So we went through, again, those 4 basic commands. You'll do this all the time: cloning, adding, committing, pushing. And we spoke about the use of Markdown. So that keeping that mindset of anyone comes to my project, they can immediately see what they need to see in the README. It's also a good way, so you can use documentation in a similar way to what some software developers do, what's called test-driven development. So some software developers, before they even write a function, they write something that tests it first. They write a small function that says, okay, this function should add two numbers together. And they write a function that says how to test it, and then they write the actual function. You can do a similar process with a README. Describe how you intend to structure your project and the scripts you intend to create in the README, and then just sort of work away at creating them. So it's a similar philosophy to test-driven development. And it's good to have flesh out the instructions for how you run your project and descriptions of the expected results. So there's lots more we could do there. I did some of these basic commands, headings, subheadings, and how to do links, because it's super useful to have this all through your READMEs. The next kind of critical rule for Git, which is maybe a little bit unfamiliar for new users, is the idea of using branches. So the idea here is, all we've done so far is I cloned what's called the main branch. So basically, there's a server that has a copy of my code. I cloned it, I made some changes, and then I wrote them. So there's basically like one version of the document in a sense, or one version of those files. A branch allows me to say, I'm going to take all of those files and code, and I'm going to create an alternative version because I want to run some experiments. Maybe I've got an idea about how to make the functions more efficient, etc., but I'm not 100% sure it's going to work. So I'm going to branch it so that my original line remains as it is, and I can hammer away at the code as much as I want. And if I test it and I'm happy with it, I can push that back. If I'm not, I can just get rid of it, and my original code remains kind of changed. So it's great for what software engineers call refactoring, which is say you've written a really, really, really long function. You think, oh, it's a bit messy, I want to clean that up a little bit. But it's like cleaning your room. Cleaning up's a daunting task. It'd be nice if you could take a snapshot of your room before you start cleaning, so you know you don't throw anything away that you don't intend to. So that's the kind of philosophy behind it. So the command is super simple. I'm going to write git grit checkout. Now, checkout is how you choose. So what's happening behind the scenes in the server? Every time you're pushing a commit, it's maintaining different snapshots of what your code looked like at a particular point in time. So the checkout command is how you can go, so you can pull out any one version of those snapshots if you look through what's called the commit history. The checkout command allows you to pull that specific code out from that specific point in time. But it also allows you to create and check out a new branch with the -b option for branch. I can say, this is my branch. Yeah, so that is going to switch to a new branch called my branch. And another useful command to know is git status. So what git status will tell me is that I'm on my branch, and there's nothing to commit. I haven't created any new files. I haven't changed any new files. Yeah. So now I could have a look in my README file, and I can see, okay, I wanted to create this thing called process.py in the folder scripts. Okay, so I'm going to make a directory. Oops. Scripts. Yeah, terrible typing today. Make a directory scripts, and then vi scripts process.py. My new file. Let's say I'm probably going to import pandas. Import pandas as PD, like everyone does, and there'll be sort of, and then more stuff happens. Yeah, so I've spent some time writing whatever this processing script's going to be. Now I'm going to git add actually, sorry, first I'm going to show you git status without that. So git status at this point will now show me there's a folder scripts that the Git repo doesn't know about. It's saying that's a folder here on your local drive. It's not in the repository. So if I say git add scripts process.py and now do git status, it tells me, okay, I've added this new file, scripts.process.py, but it notices changes to be committed. That means I haven't actually committed it and pushed that to the repo. So git commit -m, simple kind of name, and then git push. Now it's going to warn me, I've created a new branch locally that doesn't exist on the server yet. So I have to execute this command here. And what that's going to say is when I do this push, it's actually going to create a new branch on the server and pop it into that. So if I come back to my repository over here, you'll just see straight away, GitHub is telling me I've got this new branch called my branch was just pushed 4 seconds ago. Yeah. And if I have a look here, it's in my main repo, all I have is the README. However, if I click on this drop down here, I can, oops, where is it? I can choose to look at view all branches. What's going on? My branch. I can now click on my branch, and now I can see the scripts directory there. So you'll note that particular file is only in that one branch at the moment. It hasn't affected the kind of the base of my code. Yeah. Any questions about that? Nope. Cool. Share my screen again. Cool. So simple commands there. We use the git checkout -b my branch in order to create and check that out. I can go back to main at any point in time using git checkout main, and I can delete the branch. So let's just say, for example, if I come in here, so ls -la, you can see I've got the git, the readme, and the scripts directory. Now, if I say git checkout main, oh, actually, let me quickly just, you'll see in the scripts directory, I've got process.py. If I do git checkout main to go back to the main branch of the whole repository, I've gone back to main. By ls -la, you'll see it's now removed that scripts folder with that directory in, because what it's saying is that file is only in that branch. And if I want to look at my main repo, it doesn't exist. But I can go, I don't have to fret. I can, was it called my branch? Yeah. I can go check out my branch, ls -la again, and it's back again. Yeah. So I've got these alternative versions of my code that I can freely experiment with. Yeah. And then I can delete it with the -d, git branch -d for delete my branch, which I'm not going to do yet because I'm going to show you something else with that. Cool. So the reason branch-based development is important for software engineers is because often they'll be working on some kind of production system where they're trying to develop new features, and maybe they've got 2 or 3 features going at a time in different branches, and sometimes they have to do live bug fixes because they've got users. So they'll want to check back to the main production version, create a new branch, fix the bug, push that back into the main branch, go back to the things they're working on. So they're juggling different kinds of tasks. And the same thing can be true in collaborative research projects. You might be you might be testing a variation of some algorithm, but you've got collaborators who are using the old version for analysis they're running. So you don't want to be overwriting the version of the algorithm that they're using for their analysis. Yeah. So it's good. It's a very useful tool for isolating different streams of work. Yeah. Cool. Back to the slideshow. Excellent. Push regularly. So this kind of follows along from the beauty is if you can create branches and you can isolate your work, don't be afraid to push. Get in the habit of going, okay, I'll write my function definition and maybe I'll write a simple comment that describes what the function does. I'll just push it straight away. Get it out there. Keep getting it in the branch. Don't wait until you've written 300 lines of code and then, maybe your computer dies or something goes wrong. You want to keep pushing it out there. Think about the cloud as like all these different copies of my work. Yeah. So, and it's a good philosophy. It's also similar to the test-driven development methodology. If you're thinking, okay, I do this step, this step, this step, this step, push and repeat again. It's the kind of that, it's the practice of, like writers often say, you just have to start writing. It doesn't matter if the first paragraph is terrible, just start writing, because once you're flowing, it'll start to get there. It's a similar kind of thing, sort of coding and pushing. Yeah. Cool. So final one, merge using pull requests. So if you've used to use, there's many different, the complexity of all source control systems is once you've made different changes in different places, different branches or different people, how do you pull that whole thing together to create a kind of coherent code base? So this is all, it's a problem in all systems, and you do get conflicts. Pull requests are a GitHub specific way of doing this. So what you do is once you've pushed some code to a branch, that branch becomes available to be merged back into the main branch through what's called a pull request. And so you can see that right here. If I come back to the repo, Yeah, so I'm on, yeah, so it's telling me right here, I can compare a pull request because it's recognized I've got a branch that I've just pushed to. If I click on this button here, you come to the interface. If I scroll down, I can actually, it shows me what the differences are. So it's just saying, oh, you've just got this like really simple start to this process. There's not much in there. I can, what I typically do is I might say something like, I need my glasses for that. Initial process script, yeah. Some description goes in here. Now, I can also add reviewers. So if there's other people working on this project with me here, I can add them. I might say, you know, Rohit, I want to have a look at this bit of code before it goes into the main code base. Sometimes you can actually you can set up your GitHub projects so that this is mandatory. Like there'll be certain people who have to review all the code that comes through. There's a lot of configuration, but it's also sort of the thing you can do as you're working amongst each other. You'll know who knows that bit of the code the best maybe, and you can request that they review it. So set up I don't think I have a review. Rohit's not in this. This is one of my personal repos, so I don't have a collaborator. But you know, in sort of transitional-ai or Pingala repos, that many people available who could be added as reviewers. And so once you hit the create pull request button, it will actually go through a process of testing whether it can be merged or not. So this is basically, it'll look for the code base in main versus what you've just created in your branch, looking for conflicts. If there are conflicts, you'll have to resolve them. And that's a kind of a whole separate topic really to dig into. But for most things, if you're working on fairly isolated independent pieces of code, that's not usually going to happen. And now I'm going to confirm that merge and merge that in. So then what I'll see, once that is done, if I come back to the main code base, it'll now show me that the scripts directory exists. So that script that I created that was formerly just in a branch is now in the main code base. So anyone else working with the project can make use of it. Cool.
Before you move on, just a quick question there. Over on the right of what you were just doing, you also had a thing on projects and milestones. I don't know if you've used that before, but I noticed Rotash had started doing something with that on the Pingala GitHub. And so that's a useful thing to do, to add project management tools into this.
Yeah, cool. Oh, you mean up here?
Yeah, so when you were in, but just before you pushed it.
I was in the pull request section here.
Yeah, in pull requests.
Yeah, I'm not sure. I think that page is now gone because
It's gone. Yeah, that's why I tried to signal you earlier. There you are. So if you look there, it says projects, right?
Yeah.
Well, it's got, you've done assignees, but then below that you've got projects. So what you can do with projects is you can actually create a project also at the beginning or at this point, and then you can add milestones. So you can begin to use project management approaches to managing your team. So something people should be aware of. Yeah,
GitHub has tools for doing that. A lot of people use external tools for that as well too. So at my company,
that's right.
Jira tickets, so you can link the Jira tickets to specific sort of pushes or commits, that kind of thing. So there's that kind of thing. I think it varies from project to project, but yeah, it's definitely worth being aware that it'll happen for sure. Cool. So that was point 4, merging pull requests. So the idea there is because you can add a reviewer to it, the reviewer can comment on the code, they can see all the changes you've made. There can be kind of a dialogue between you and the reviewer about how you've done certain things. Then you've got this kind of audit trail of the specific bit of work you did and the changes that were made. So again, it goes back to that point. It's not just about source control. You've got a documentation and collaboration tool for as you make these gradual changes. And it allows sort of teams, what can happen then is people who know the code base really, really well can maintain an overview on all the things that different developers are working on, and you can sort of maintain a consistency of the quality of the code. Cool. So the high-level summary is Git is super useful as source control, but it's more than that. It's now a culture of working and collaborating, and there's some really simple, even though there's variation in the way people do it, there's some norms in that are generally used by many, many different teams, which I've gone through today. You can document and link inside your repository with Markdown, which is a really simple and easy to use way of writing documentation. There's other useful things with Markdown too. You can generate PDFs from it as well too. So you can actually write, simple documents and share them around a PDF format if you need to. Branches encourage you to innovate and experiment freely without sort of risk of losing work or damaging code. And this process of branching and then pull requests allows for audited merging of your work, and the visual interface for code reviews is really nice, just seeing the differences across the different files that might be in a given submit. Thanks for your time. Oh no, future topics, that's right, I forgot. So there's a bunch of other stuff I could cover. Useful feature that I use on some of my personal projects is PyTest with GitHub Actions. So if you write Python test functions, then I have them set up with a GitHub action. Every time I do a push, it runs tests over my code and tells me if I've broken anything. So particularly useful if I'm trying to look for a more efficient way to write certain parts of the library. PyTest with automated actions is really, really useful. You can automate a process of code documentation using the Sphinx project and the website Read the Docs. So basically, you can write a simple kind of introduction to how to use your code base in another Markdown format with Sphinx, but also set it up so that it will generate a sort of linkable API documentation for your code. So it'll scan your code, pull out the doc string from your functions, and create a kind of like style Markdown style file so that people can use it as an API. Super useful if what you want to use GitHub for is writing your own Python libraries that other people might use. And then finally, the other thing that I can go through in the future is simple ways to create an installable code base with setup.py and PyPy. Basically, make your code something that people can install into their local installation with PyPy, or just clone it and then install it so it now becomes like a Python library or a command line application. Cool. Thanks for your time.
John.
I've got to get here, Rodney, first. Sorry, mate. Okay. All right. Rodney?
Yeah, just before you go, I've got a wish list for your future topics, which something that you didn't include there is GitHub security and authentication.
Okay. Yeah.
Right, because without that, you're not going to be able to get it to work.
Yeah.
Yeah.
Oh,
so
good.
That would be great if you could do a talk on that.
Will do. Okay, I'll just add it into the start of the next one. Yeah.
Okay, other questions?
Yeah.
Okay, so does it mean that for you to create all the stuff, it had to be done in the terminal, right?
It doesn't have to be. I just like using the terminal. I'm just very comfortable, and there's plenty of other tools. I just find I like using it, and it's kind of easy to illustrate because you can just see specifically what the command is and what the effects. Yeah.
As much as we learn this one, I also like next time other factors we can equally use and we can compare and contrast, which is okay for us and better.
Yeah.
Because it might be suitable for you and somebody else might not be suitable for it. So
Yeah. So there's a couple of options there. I mean, some development environments have Git functions built into them, so you can sort of point and click, say commit or push or merge, that kind of stuff. And there are standalone applications for Git, like their own UIs. I'm actually not that familiar with most of them because I know I'm always going to have a terminal, so I just use the terminal.
Okay, other questions? Okay, then thank you, John, for this excellent presentation.
Thank you. Thank you, everyone.
Stop the record.
This one here? Oh, just here. Oh no, I did the wrong thing.